Hello everyone, all my dear students. In our last video lecture, we had seen this full adder circuit. We had seen the full adder circuit, but the full adder circuit we had seen by using the half adders. If you not seen that video lecture, then I will provide its link in this I button, or I will give the link in the description box. Okay, here we have to see the full adder circuit, but that full adder we have to construct by using the three number of the AND gates, one XOR gate and one OR gate. Here there are various types of the questions which are asked on this full adder. So first question is what is the full adder? What is the full adder circuit? Explain it with the help of logical diagram, and the truth table. Now in this question, the specify is not done. That we have to write down the answer by using the full adder, and that full adder is either constructed by using the two half adders or the other type. So here you are free to draw any one circuit from these two. Either you can use the type 1 circuit. That type 1 is by using the full adder, by using the two half adders, and the type 2 circuit by using the three numbers of the AND gate, one XOR gate and one OR gate. Okay, so here in this first question you are free to draw the logical diagram, which is easy for you. Okay, then the same you have to explain and you have to draw its truth table. The second one is define the full adder. Define the full adder. The definition of full adder and what is full adder, both are same. Okay, then you have to draw the logical diagram. By using the half adders, and you have to explain its working. Okay, then the next question is also there. Again, there is a define a full adder. You have to define what is the full adder. Then you have to draw the logical diagram using the AND gate, OR gate and XOR gate, and you have to explain its working with the help of the truth table. Okay, so here all these three questions are similar, just you have to define at the time of the question. Okay, so here in the only first question you are free to draw what type of circuit you like, and in other two questions there is a specified logical diagram. Okay, now in this video lecture we have to see the full adder again, but that full adder circuit is constructed by using the three number of the AND gates. Here we can construct this circuit by using three AND gates, but these three AND gates are the two input AND gate. These three AND gates are the two input AND gate, and with this two input, three numbers of the AND gate, here we require to use the other gates also. One XOR gate we have to use, but that XOR gate is the three input XOR gate. That XOR gate is three input XOR gate. How many we have to use? Only one number we require to use. Here you have to keep in mind one thing. What is that? The XOR gate available in market, that XOR gate is only the 2 input XOR gate. So you have to construct the 3 input XOR gate if you have to do the practical. Okay. Then the third gate we have to use. That third gate is 3 input OR gate. That third gate is the 3 input OR gate. Okay. If you remember the logic diagram of the half adder, in that half adder we use the AND gate and the XOR gate. We use the AND gate and the XOR gate. The AND gate we use for generation of the carry and the XOR gate we use for this sum. But here one question comes, and that question is why we are using this OR gate. We required to obtain only one carry. So therefore here to obtain only one carry we require to use one OR gate. Okay. So here these 3 gates we required for the construction of the full adder by using the 2 input AND gate, 3 input XOR gate and 3 input OR gate. Okay. Here the AND gate we require to use, that AND gates are the 3 AND gate. Okay. So we will see how we can construct this full adder circuit, and here what type of the truth table is formed by using this full adder circuit. Okay. So for the construction of the full adder, here we require to use 3 numbers of the AND gate. Okay. So 3 numbers of AND gate we are using, and 1 number of 3 input XOR gate and 1 number of the OR gate we are using. So how we can construct it? For that purpose, here once again we recall the full adder circuit's definition or the logical statement. So this full adder is a logical circuit, and this logical circuit having 3 number of inputs. 3 inputs are there. The 3 inputs and the 2 outputs are there, and we can say the full adder performs the addition of 3 binary bits. It performs the addition of 3 binary bits, and it produces the output in the form of sum and carry. It produces the output in the form of sum and the carry. So here this is we call as a full adder. Now we require to draw the logical diagram for this full adder, then we'll explain this full adder. But how we can draw it? By using the 3 numbers of the AND gates. 3 AND gates we require to use. Suppose we have the 3 inputs, and these 3 inputs are A, B, C. These 3 inputs are A, B, C. A, B and C, these are the 3 inputs. Okay. But how we can apply it? Here we have to make such an arrangement where the AND gate having the 2 input, every AND gate having the 2 input from the 3 available input A, B, C. Okay. So for that, here I am going to draw first 3 numbers of the AND gate at this side. Here the 3 AND gates I am going to draw. These are the 3 AND gates. The 3 AND gate outputs are applied to the XOR gate. The 3 AND gate outputs are applied to the XOR gate, and here the 3 AND gate outputs are applied to the OR gate, and here this OR gate we use for generating the carry. It means here the output of the AND gate is the carry output between the 2 binary bits. So here to the first AND gate we apply the input, 2 inputs from the 3 actual binary bits. So these 3 input these two inputs are A and B input. For the second gate, the inputs are B and C, and for the input for the third AND gate, the inputs are A and C. Okay, so these AND gates having the inputs, these inputs are the binary bits. Okay, the outputs of these all AND gates, these three AND gates, we apply at the OR gate. Okay, so here I am going to draw one OR gate. This OR gate is having the three inputs. These inputs are taken from the outputs of the AND gates. Okay, so here the first input AB, second input BC, and the third input, that third input is the AC. Okay, so three inputs are there, so its output is Y, and that Y is the carry. The carry equation is given by Y equals to AB plus BC plus AC. The output of this OR gate is considered as a carry, and its equation is Y equals to AB plus BC plus AC. Okay, now here the important is how we can apply the inputs to the all AND gates. Okay, so for application of the input to the all OR gates AND gates, here we require to use the common data lines. Okay, so here we are going to draw the data lines. Here is the first line, and that first line is the A line. That first line is the A line, or we can say it is the C line, and the other lines are for the B and the C. Okay, so here is the input A, then here it is the input B, and this is the input C. These are the input lines. These input lines we have to connect with the first AND gate. Here this one is we call first AND gate, this is the second one, and this is the third AND gate. Okay, so here we have to apply the input to the AND gates. The AND gates we are using here to generate the carry in between the two binary bits. So the first AND gate generates the carry in between AB, the second AND gate generates the carry in between BC, and the third AND gate generates the carry in between the AC. Okay, so here we apply the same inputs to the AND gate. Here is the first input. That input is we call the A input. So here I am going to apply the input A. Then the second input for the first AND gate is the B input. So this one is the B input. Then here for the second AND gate, the inputs are B and C. So here is the B input available. Here I am going to apply the B input. Then the C input is there, so here the C input is applied, and to this lower AND gate, the third AND gate, we apply again two inputs. These are the A input and the C input. Here is the C input. Okay, so here the three AND gates we are using to obtain the carry between the two binary bits, and then we apply the outputs of the AND gate, the individual AND gates, to the OR gate to generate the final carry, which is having the equation, and that equation is Y equals to AB plus BC plus AC. Okay, now we have to draw the XOR gate. As we know, the XOR gate we are using for the sum. So here all of the inputs we apply to the XOR gate. This is here the XOR gate, and the XOR gate output is the sum output. Here this one is the sum output. Okay, the three inputs we apply to the XOR gate, and these three inputs are A input, then B input and the C input. Okay. So here I am going to apply the inputs to the XOR gate. The first input is the A input, second input is the B input, and the third input is the C input. First input is the A, then second one is the B input. Here is the B input available, and the third one is the C input. Okay, so that's why here its output equation is sum y equals to A XOR B XOR C. Okay, so this is the logical diagram of the full adder circuit by using the three AND gates, one XOR gate and one OR gate. Here the inputs are A, B, C. From these three inputs, two of them we apply to the first AND gate, two of them we apply to the second AND gate, and the remaining two we apply to the third AND gate. We have to make the combination of the two binary bits from the three binary bits. First one is the AB, then second one is the BC, and third one is the AC. The AND gate we are using for generation of the carry. So here the three carries are obtained. We require only one carry. So to obtain only one carry, we are using here the OR gate, and the inputs to the OR gate are AB, BC, and the AC. The output from the AND gates. Okay, the OR gate output is the final output, and we are using this XOR gate for this sum output. So all these three inputs A, B, C we apply to the XOR gate, and its output is y equals to A XOR B XOR C. Okay, so here this is a logical diagram. Okay, here if there is a question, then the writing sequence is same as that of the previous full adder. What we did in previous full adder, first we return the logical statement or the meaning of the full adder. After that we return the construction of the full adder. In that you have to write down the full adder is constructed by using three number of the AND gate, one OR gate, and one 3 input XOR gate. The 3 input bits are there. From that the combination of the first two bits is applied to the first AND gate. Then the second combination of the 2 bit from the 3 binary bit is applied to the second AND gate, and also applied to the third AND gate. The output of these all 3 AND gates are applied as an input to the OR gate, and this OR gate output is considered as a carry, and the carry equation is given by y equals to AB plus BC plus AC. All these three inputs A, B, C are applied to the XOR gate. So the output of XOR gate is considered as a sum, and its equation is given by y equals to A XOR B XOR C. Here there is a equation. Okay. If it produces the output as that of the mental addition, then we can say this circuit works as a full adder. Here we apply the input. From that the first input is supposed to be 1, second input is 0, and third input is equals to 1. We are applying the inputs. So here A is equals to 1, B is equals to 0, and C is equals to 1. A is equals to 1, B is equals to 0, and C is equals to 1. A equals to 1, B equals to 0. It means the output of this first AND gate is equals to 0. Here I am going to write down the output of the first AND gate. B is equals to 0. It means here again the output of the second AND gate is also equals to 0. C is equals to 1 as well as the A is equals to 1. So therefore output of this third AND gate is equals to 1. Okay. Here the AND gate produces logically low output when its any one input is logically low. Otherwise we can say the AND gate produces logically high output when and only when its all inputs are logically high. Okay, these three inputs 0, 0, 1 are applied to the OR gate and this OR gate produces carry is equals to 1. The logic statement of the OR gate here we have to use, and by using the logical statement here we can say the output of this OR gate is equals to 1. Okay, if you not seen the video lecture of the logic gates, basic logic gates, then I will provide its link, its button in this iCard. Okay, so here the inputs A, B, C, that is 1, 0, 1 are applied to the XOR gate. The inputs A, B, C, 1, 0 and 1, these are applied to the XOR gate. Here the output of XOR gate Y is equals to 0 because the even number of logically high inputs are applied. Okay, so we get here the inputs are 1, 0 and 1. We get here the carry is equals to 1 and sum is equals to 0. Okay. Now if we apply the different inputs, for an example, suppose the inputs are A is equals to 1, B is equals to 1 and C is also equals to 1. The three inputs we apply and these three inputs are 1, 1, 1, means the binary bit which we have to add, that binary bits are 1, 1, 1. Okay. Now the input for the first AND gate, the input for the first AND gate are A and B. A is equals to 1 and B is equals to 1. The input for the second AND gate are B and C. Here B is equals to 1 as well as the C is equals to 1. So its output is equals to 1. For the third AND gate, the inputs are again same. A and C both are 1, 1. So therefore here the inputs for the OR gate are 1, 1, 1. And here this OR gate produces logically high output which is carry equals to 1. Okay. Now here the same inputs A, B, C, these same binary bit are applied to the XOR gate and here the output of XOR gate is A XOR B XOR C. The XOR gate produces logically high output. The XOR gate produces logically high output because here its all inputs are logically high and all these inputs are the 3 input and the 3 input means the odd number of logically high input. So therefore its output is equals to 1. If we add the binary bits 1, 1, 1, then we get the sum is equals to 1 and carry is also equals to 1. It means here the logical circuit which we had constructed, that logical circuit produces the same output as we add it mentally. Okay, so here we can say this logic circuit is a full adder circuit. Okay, now this we can all write down in the working section. First we write down the meaning, after that we write down the construction, after construction we draw the logical diagram and the symbol of, we have to draw this one logical diagram and this symbol of the full adder and then we write down its working. But in working here you not need to write down the working principle or the logical statement of all these gates we are using here. You have to write down such as the AND gates we are using, these AND gates having the inputs from A, B and the C binary bits. The combination of the two binary bits is applied to the individual AND gate. If the inputs are A is equals to 1, B is equals to 1 and C is equals to 1, then the output of all of the AND gate is equals to 1. Or you can take the other example, instead of 1 1 1 you can take the 1 0 1. At least two examples we required in which the carry is equal, the sum is equals to 0 in first example, and in second example the sum is equals to 1. Or either you can change the example as per your need. You may take the example having the carry is equals to 0 and sum is equals to 1, or you can take the example as carry is equals to 0 and sum is equals to 0 and carry is equals to 1. But you have to write down the all possible combinations of the inputs for A, B, C in the truth table. Okay, so here after working we have to draw the truth table, and the truth table having the three combinations of the input. Okay, here we will draw the truth table for the full adder. Truth table for the full adder. In this truth table, what we have to mention? Here many truth tables we had seen. The truth table is a table in which all possible combinations of the input for that particular circuits are mentioned along with their respected outputs. Okay, we are going to draw the truth table, and in this truth table we apply the inputs. That inputs are A input, B input and the C input. These are the three inputs. After this, here the two outputs are there. Which are those outputs? The carry output. Here is the carry output, and then this sum output. So this one here, this sum output. Okay, so the combination of the inputs we have to apply. The three inputs are there, so the total number of combinations are the 8 number of combinations, and here the first combination becomes A is equals to 0, B is equals to 0 and C equals to 0. At this time we get the carry is 0 and sum is also equals to 0. When we use the next combination is A equals to 0, B is equals to 0 and now C equals to 1. At this time we get the carry equals to 0 and sum is equals to 1. When A is equals to 0, B is equals to 1 and C is equals to 0. At this time again we get the carry is equals to 0 and sum is equals to 1. When A is 0, B is 1 and C is 1, at this time we get the carry equals to 1 and sum is equals to 0. When the A is 1, B is 0 and C is 0, here we get the carry equals to 0 and sum is equals to 1. If we apply the same inputs to the logical circuit which we had seen earlier, we get this same output. Okay, so the next combination we can consider, and that is A equals to 1, B equals to 0 and now C is equals to 1. We get here the carry equals to 1 and sum is equals to 0. Next combination becomes A equals to 1, B equals to 1 and C is equals to 0. We get here the carry equals to 1 and sum is equals to 0. Then the next combination is all inputs are 1 1 1. The example which we had seen along with their outputs. Okay, so here we get the carry equals to 1 and sum is also equals to 1. Okay, so here you have to draw this table after the working of the full adder. Now we will see again the writing sequence for this full adder using the gates, or we can say using the 3 number of AND gate, one 3 input XOR gate and one 3 input OR gate. Okay, so first of all you have to write down here the meaning of the full adder. Whatever the question from these three questions. We had seen the three questions. From that, the first question is, what is the full adder? Explain it with the help of the logic diagram and the truth table. It means you are free to draw the full adder circuit by using either the half adder or by using the gates which we had seen earlier. Okay, so here you have to draw the logical you have to first write down the meaning of the full adder. Meaning of both the full adder, either it is type 1 or it is type 2, both are same. After this meaning of full adder, you have to write down the construction. But the construction of the full adder depends on what type of logic circuit is asked in the question. If they ask, explain the working of full adder using the two half adder, then you have to write down the construction of the full adder using the two half adders. If they ask, explain the working of the full adder using the 3 AND gates, 1 XOR gate or 1 OR gate, or they may ask like this, explain the working of full adder using its logic diagram using the gates. Okay, then you have to write down the full adder using the 3 AND gate, 1 XOR gate and 1 OR gate. Okay, so construction depends on the question asked. Okay, so here we have to draw the construction. We have to write down the construction. In construction, you can write down the 3 binary bits are there, and from that here we make the combination of the 2 binary bits such as AB, BC and AC. These are applied to the AND gates, individual AND gates. To the first AND gate we apply AB, the second AND gate we apply BC, and to the third AND gate we apply AC. The outputs of the AND gates are applied to the OR gate, and the output equation of that OR gate is given by AB plus BC plus AC. Okay, the output of this OR gate is considered as a carry output. After this, here you have to write down the input binary bits. The input binary bits A, B, C are applied as input to the XOR gate, and the XOR gate output is considered as a sum output. Its equation is given by A XOR B XOR C. Its equation is given by A XOR B XOR C, and here you have to stop the construction. After this, you have to write down the working, but while writing the working, here you have to take the 2 examples. The examples are from these combinations of the input. You can take either this one combination 1 0 1, this one combination, or you can take the second combination which is 1 1 0. You can take either the 1 0 1, or you can take 1 1 0, or you can take the 1 1 1. The 2 input combination you have to use, and accordingly you have to write down the output, carry and the sum. Okay, after that you have to draw the truth table. Means first you have to write down the meaning of the full adder, then you have to write down the construction of the full adder. After that, here you have to write down the working details of the full adder, and for the working details you require to use at least two examples from the truth table, and then you have to draw the truth table. Okay, so first you have to write down the meaning, then construction. After construction you have to draw the logical diagram. logical diagram and the construction is same, but we have to write down few lines about the logical diagram. Then in working detail you have to take the two examples and at last you have to draw the truth table. Okay, along with the logical diagram here, if there is a space then you can draw the symbol of the full adder. So this is all about the full adder by using the three numbers of the AND gates. These three numbers of the AND gate, one OR gate and one XOR gate. You have to keep in mind the combination of the two binary bits from these three, combination of two binary bits from these three binary bits you have to apply to the AND gate, and the output of the AND gate is applied to the OR gate. So this is all about the full adder logic circuit.